Good morning. This lesson is kind of, it's not like a bonus lesson. It's something that we need to cover in Algebra 2, but often I have trouble like fitting it in somewhere. And it's a lesson on something called the discriminant. So the discriminant is part of the quadratic formula. I'm going to put the quadratic formula up here. We have x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is this part of the quadratic formula. It is just the b squared minus 4ac, which is the part that's the most error prone. The students do have kind of issues with when doing the quadratic formula. We talked about like the opposite of b over 2a. That's like the vertex. We use that to find the vertex. The discriminant actually can tell us what types of answers a quadratic equation would have. So the discriminant tells us not what the answers are, because the answers we have to do the whole formula. But the discriminant tells us the type of answers a quadratic equation has. And I'll explain what that is. So if you're looking at the actual notes, the way this lesson is structured is we would split up into 3 groups, and each group has its own quadratic equation to find. And what we would do with the solutions is we'd solve them with the quadratic formula, and we would look at the discriminant, and then we'd look at what the solutions actually were. I'm actually going to approach this today a slightly different way. I'm going to give you the end game, kind of where we're going to drive with this, and then we'll go back and use those group work problems to illustrate it. So here's the end game. Here's what we know from the discriminant. So if you had a quadratic equation and you just did the b squared minus 4ac, that's the only part you did. If you got a positive number for the b squared minus 4ac, then you would know that it has 2 real answers or 2 real roots. Okay. Now, as a subheading for this, if you get a perfect square, okay, so you get something, you can take the square root of a perfect square, it means it is factorable. So this is sometimes how teachers or people that are very experienced in math, before they spend a long time trying to factor something that's really hard to factor, is they'll check the discriminant to see if the discriminant is a perfect square, because if it's not, then it's not factorable and you don't even want to bother trying to factor it. If you get 0 for the discriminant, it means you have 1 real answer. And if you get a negative for your discriminant, it means you have 2 complex answers. And prior to this, I'm going to fix my arrow right there. There we go. That's better. Prior to this studying imaginary numbers, when you're doing the quadratic formula, if you got a negative under your square root, like you were done with the problem. You're like, what's this negative under the square root? What does that mean? That's like nothing. But once you study imaginary numbers, then you're able to actually navigate through the negative under the square root, if you think back to our first lesson on imaginary numbers. So what I have in the lesson is I have 3 examples of quadratics, and instead of breaking up into groups, I'm just going to work through them and explain what they are. We're going to look at the discriminant, and then we'll actually solve the problem, and like you'll see the connection here. But this is the key idea. This is like the end game. So the first example was this. It was x squared plus 3x minus 28 equals 0. A is equal to 1, B is equal to 3, and C is equal to negative 28. If you just do b squared minus 4ac, we have 3 squared minus 4 times 1 times negative 28. And that ends up being 121, which is positive. And it means that when I solve this problem, I will get 2 real answers for it. So let's go ahead and solve it. And I'm not going to reinvent the wheel. I know that this is equal to 121, so I'm just going to use that when I use the quadratic formula. So we've got x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b would be negative 3 plus or minus the square root of 121. I'm just not going to redo that because I just did it. And then this will be over 2 times 1. Now notice that the square root of 121 is equal to 11. And that means it's a perfect square. 121 is a perfect square. Yeah, I have to stop and think about that. Is a perfect square. So that means that this equation was factorable and we didn't really need to do it with the quadratic formula, and under normal circumstances you probably wouldn't. So we have negative 3 plus or minus 11 over 2, negative 3 plus 11 over 2, which is, what is that? 8 over 2, which is 4. And the other one would be negative 3 minus 11 over 2, which is negative 14 over 2, or negative 7. And so we've got 2 answers, and the answers are both real numbers, 4 and negative 7. Both of them are real. Somehow on my iPad, I got this set for 2 reds. I didn't really want to do that. Now, just for the sake of illustrating that this is factorable, you want 2 numbers that would multiply to negative 28 but add up to positive 3. That would be positive 7 and negative 4. And when you go to solve that, we'll apply the zero product property in there. We subtract 7 from both sides to get negative 7 and add 4 to both sides to get 4. And much, much easier to solve using factoring than the quadratic formula. But again, the lesson's on the discriminant. So we know, because we got a positive, that we were going to have 2 real answers, because a positive means you have 2 real numbers for your answer, and because it happened to be a perfect square, it was also factorable. All right, next one was this equation. This was x squared minus 10x plus 25 equals 0. So a is equal to 1. B is equal to negative 10, and C was equal to 25. So again, we're just doing the discriminant, B squared minus 4AC. Always use parentheses there, okay? I know back here it wasn't necessary to put the parentheses because B was positive, but as soon as B is negative, you have to have the parentheses there. So if you always do it, it won't be an issue. A is 1 and C is 25, and this ends up being 0. So you would have a 0 under the square root. Well, according to this, 0 means you have 1 real answer. And the reason for that is because when you add 0 and you subtract 0, that's the same thing. And so you end up getting the same answer twice. So let's go ahead and work that out. We have x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. In this problem, b was negative 10, so the opposite of negative 10 is 10, plus or minus the square root of 0. Don't overthink this. 0 is my favorite number for a reason. The square root of 0, you're asking what times itself gives you 0. That would be 0. So we'd get not that, 10 plus or minus 0 over 2. But observe, 10 plus 0 over 2 is 5. And if you have 10 minus 0 over 2, that's also 5. And so really you have 1 answer, and it's real. 5 is a real number. The way that looks with your factoring, because 0 is a perfect square, so it's going to be factorable. you'd have the x squared minus 10x plus 25 equals 0. That factors into x minus 5 twice. And so you get the same factor twice. And so you would end up with the same equation there twice. You'd add 5 to both sides and you get 5 out twice. So that's actually called a double root or a double zero, where it shows up 2 times, and it does impact the graph of it. And what I'll probably do at the very end of this lesson is just show you what that means for the graph. So if you have a positive number, you get 2 answers, and they will be real. They might be irrational, so they might still have like a square root in them, okay? But remember, square roots are still real. If you get a 0 for your discriminant, you will have 1 answer, but it will turn up twice. And now the last one, if you get a negative number under the square root, then you have 2 complex answers, meaning you will have an I. So let's go look at that last one. This is x squared minus 4x plus 7 equals 0. A is equal to 1. B is equal to negative 4. And C is equal to 7. We're only looking at the discriminant. We're looking at b squared minus 4ac. Please put that b squared, like just put it in parentheses, just for me. Okay, so times 1 times 7. This ends up being 16 minus 28. Which is going to give you a negative 12. And so that means we are going to have 2 complex answers. Let's go see what that looks like. So we've got the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Opposite of b. B was negative 4 in that problem. So the opposite of b would be positive 4. We're not going to reinvent the wheel. We already did the discriminant back on this slide here, so we're not going to redo it. Over 2 times 1. Now let's do a little bit of scratch work over here. Negative 12, if I need to simplify this square root, this would be 4 times 3 times negative 1. I'll give you a moment to see what I did there. Square root of 4 times the square root of 3 times the square root of negative 1. Square root of 4 is 2. Square root of negative 1 is I. And then you can't really do anything with the square root of 3. Now what we do here is we're going to move that I, kick that I over to the front. So we're going to write that as 2I root 3. So 4 plus or minus 2I root 3 over 2. And I don't have any more space. Oh, this is no good. So we're going to have 4 plus 2I root 3 over 2. And then we'll have 4 minus 2I root 3 over 2. And you actually can do this one out where you divide out the common factors. So we would have like 4 over 2 plus 2I root 3 over 2. 4 over 2 is 2. And then right here, if you see where I'm pointing, 2 over 2 is 1. Giving us I root 3. And then you could do the same thing over here. 4 over 2 is 2. And 2 over 2 is 1. And you'll notice that the answers both have I's in them. And you have these complex answers. And that's what the discriminant can tell us. So once in a while on like standardized tests and stuff, you'll see a question that isn't necessarily solve the quadratic equation, but it will be something like, what kind of answers do you have? And what they're driving at is, do you have 2 real answers, 1 real answer, or 2 complex answers? So what I'm going to do on the next slide is I'm going to summarize that, and then we'll just quickly take a look at what that means for the graphs. And then I don't know what we're going to do because I'm recording this like 2 weeks ahead of when we're going to do it. So I have no idea what this is going to look like. Stay tuned. All right, last thing. Again, this is like the summary. So if b squared minus 4ac is positive, you'll have 2 real answers. If it's 0, you have 1 real answer, but you're going to get it twice. If it's negative, you get 2 complex answers. I do want to point one thing out here. Notice that the complex answers always come in groups of 2. So your real answers, you can have 1 of them, but your complex answers always come in pairs. So you will never have just one complex answer to a quadratic equation. Last thing I just really quickly wanted to touch on is what does that mean for the graphs? So if you were to graph these quadratics, it's been a little bit of time since we've dealt with some graphs. What did these answers mean? Like, why does anybody care about it? You're probably thinking nobody cares about it. Somebody does. 2 real answers means this. It means that your parabola will cross the x-axis twice. If you think back to some of the applications we were doing, when you go to, you have like y equals, let's actually change it up. The task cards, we had stuff like h equals negative 16t squared plus 8t minus 3. And if you wanted to know when does it hit the ground, you would have the 0, and then you would solve the equation. And if you remember, when the height was 0, that was the x-intercept. So that's going back to the task cards. And when we talked about like when does it hit the ground or where does it hit the ground, how long is the object in the air, we were always talking about the x-intercept, and that's where we plugged in the 0. So all of those equations that we looked at had a 0 on one side, and when you go to solve them, you always put a 0. So your answer to the equation is the x-intercept. What this means is that you have 2 x-intercepts. Now, if you have 2 real answers means 2 x-intercepts, then 1 real answer probably means 1 x-intercept, and this is what it would look like. It would actually come down, touch the x-axis at the vertex, and then turn around and go back in the other direction. So this one like actually crosses the x-axis and then crosses again. This one would come down, touch it right on the vertex, like it's just sitting, and then it would turn around, and it counts like twice. It's almost like it counts coming down and counts going up. Now, negative 2 complex answers, well, what on earth does that mean? That means that you actually do not have any x-intercepts. It means your parabola is floating up here and it never makes it to the x-axis. So what's neat about this lesson, one, sometimes discriminant, like it's a vocabulary word you should know. It can tell you if a quadratic is factorable, and it tells you the kinds of answers that you can get. It also tells you a little bit about what the graph looks like, whether you have 1 x-intercept, 2 x-intercepts, or no x-intercepts. So because remember, this is all real numbers and this is real numbers. So the fact that you've got complex answers means like it doesn't intersect these real number lines. So that's pretty much it. And I will give you details about how to get a grade for this, which at the time of this recording, I have no idea what it is. Hopefully we'll do this lesson the last day before the break. So everybody have a great break. Happy holidays. And I'll see you in the new year.